Industrial gases like oxygen, they're literally the lifeblood of our modern world, from hospitals to heavy manufacturing. We just expect them to be there. But what happens when the simple steel cylinders that hold them become a deadly liability? We're about to uncover the hidden dangers of this industry, all through one tragic incident that exposes a critical and honestly an often overlooked flaw in the whole system.
Yeah, that's a pretty stark warning from industry experts, right? And it gets right to the heart of what we're talking about today. See, this isn't just some theoretical what-if scenario. It is a very, very real danger. And as we're about to see, it has already cost people their lives. So to really understand just how serious this is, we need to look at a specific event. This isn't about us reading some dry safety manual. Nope, this is a real-world case study, one written in tragedy. And it all centers on a single, devastating explosion in a place called Mohali.
So picture this, August 6th, 2025. It's just another routine day at a plant in Mohali. And then, out of nowhere, a catastrophe. A single cylinder ruptures, setting off this horrific chain reaction. 2 workers were killed, and several more were seriously hurt. I mean, the blast was so massive it actually threw debris into neighboring villages. So you have to ask, right? How on earth could something like this happen?
Well, the answer? It's not as simple as just one faulty cylinder. It's actually way bigger than that. It's about a fundamental shift in how the entire industrial gas business operates, a shift that quietly and dangerously transferred risk away from complex machines and onto everyday human procedures. Okay, so here's the deal. The core of the problem started with a change in the business model. That plant in Mohali used to be what's called an air separation unit, or an ASU. They made their own oxygen right there, and you needed technically trained, qualified people to run the place. But then they switched to being a liquid bottling unit, or an LBU. And in that model, all they do is buy huge tanks of liquid oxygen and just fill up cylinders. The really crucial difference? This kind of work is often done by general, sometimes untrained labor. Suddenly, safety wasn't about the tightly controlled system anymore. It became almost entirely dependent on the condition of those cylinders and the people handling them. Okay, so with this new risk profile in mind, let's really dig into what went wrong in Mohali. Where exactly did the system break down? The first place your mind goes is the machinery, right? Was the cryogenic equipment itself just flawed? Were the tanks, the pumps, the valves, were they built on the cheap or something?
Well, the investigation came back with a clear answer. Absolutely not. Turns out, the components in these modern bottling units are incredibly high-spec. I mean, we are talking about surgical-grade stainless steel tanks built to super strict engineering standards, valves designed for a perfect seal, and pump parts tough enough to handle temperatures of -200 degrees Celsius. The technology itself was engineered for safety, so no, the problem wasn't the hardware.
So, if the million-dollar filling equipment wasn't the issue, what does that leave? It forces you to look at the thing being filled, the cylinders themselves, and that completely pivots the investigation away from the big complex machinery and onto the hundreds of individual steel containers being handled every single day. And bingo! This is where we find the absolute critical failure. You see, every single high-pressure gas cylinder is required by law to go through something called a hydrostatic test. It's a pretty simple check, really. You fill it with water, and you pressurize it to find any metal fatigue, any corrosion, any tiny little leaks that could lead to a catastrophic failure. And in Mohali, this mandatory life-saving procedure was just skipped. Look, the tragedy in Mohali didn't have to happen. It was the direct result of neglecting established, non-negotiable safety rules. So what are these commandments, if you will, that can prevent this from ever happening again?
Okay, the first set of rules is all about verification and testing. Number 1, and this is the big one, that hydrostatic test we just talked about has to be performed on every cylinder, every 5 years, with meticulous records, no exceptions. Number 2, plants need annual safety audits from independent third-party experts to make sure they're complying with all the regulations. And number 3, something that should happen every single day, a simple visual inspection of each cylinder for damage and a valid test date before it ever gets connected to the filling line.
All right, next up, it's all about operations and people, because the best equipment in the world is useless without skilled operators. So all personnel must be trained and certified in handling these super cold cryogenic liquids. The filling process itself needs to be optimized, using automated systems wherever you can to prevent dangerous overfilling. And finally, it is not enough to just have emergency procedures written down in a binder somewhere. You have to drill them regularly, so when an emergency does happen, the response is automatic and effective.
And the final set of commandments covers maintenance and monitoring. A preventative maintenance schedule isn't a suggestion, it is a lifeline for the entire facility. This means keeping critical spare parts like relief valves and seals in stock at all times. It also involves optimizing the system to minimize product loss, which isn't just about efficiency, it's a huge part of being safe. And last but not least, plants need real-time monitoring with alarms for pressure and temperature, so the system itself can warn you of a problem long before it becomes a disaster.
So, we've walked through a terrible tragedy, we've looked at its causes, and we've laid out a whole set of solutions. But what's the single most important takeaway from all of this? If you remember just one thing, what should it be?
It all comes down to this number, 5. 5 years. That's the mandatory interval for a simple test that verifies if a steel cylinder can safely hold all that immense pressure. It's such a small number, but it represents a massive commitment to safety. And forgetting it, well, that has deadly consequences.
So here's the bottom line. This industry shift to the more flexible liquid bottling units has placed the burden of safety squarely on human procedure. You can have the best engineered tanks and pumps in the world, but they mean absolutely nothing if you're filling a cylinder that's a ticking time bomb. And that just proves it, doesn't it? Safety is never a line item you can cut. It is the fundamental, non-negotiable investment that makes the entire operation possible.
We see these cylinders everywhere, at hospitals, construction sites, workshops. They are a silent, essential part of our modern world. And that leaves us with a critical question to think about the next time we see one. Is the company that filled it investing in safety, or are they cutting a corner, just hoping this one isn't a ticking time bomb?